telnet A, and it is executed from host C. Okay, and C, if you can see something, it is on the left. Okay, so here's one thing. Since the thing is becoming complex, here's one advice for you. Okay, what you need to do from the beginning is that on the figure, okay, on the figure you have tried to put directly the IP addresses and the MAC address, because otherwise you will have to go all the time to the text. So to avoid that, first thing, let us put IP addresses and so on. So what is the IP address of host C?
131.204.27.10.
Okay, yes. So what you will see is that I will put this time 2 numbers, because it happens that on this exercise, the first part is the same for all the machines on this example. What changes, you can see, this is what makes that we have different networks, okay? So I will put, remember, so far I put only the last, okay? Because the 3 first numbers of the IP address were the same, okay? But here, to make difference, I have to put the 2 digits. So what is the address of, what should I put for A?
14.173.
Yes, I need to put 14.173. B, what is its address?
14187.
14.187. And the DNS?
14.2.
14. Oh. 14.2. Okay? Observe one thing. A, B, and DNS are on the same network. Okay? Even though they are separated by a bridge will be connecting machines that are on the same network. From the view of IP, for IP, A, B, and DNS, and sure enough, they all have that 14. They are on the same network, okay? And this, I know it through the mask, okay? The mask, it says normally I have to look at the first 24 bits, right? To take the net. And this is what makes the difference. Now, for the Ethernet address, of course, this is easy. C is EC, A is EA, we have EB, and DNS is ED. That will help me. Okay? Right? So we start from the machine C, trying to do telnet to machine A, right? Okay. So you have to follow exactly what each protocol somewhat does. Okay. Telnet to A. That means telnet needs to open a connection through which protocol?
23.
No, okay, remember, the server is on port 23, okay, but which transport protocol will it need?
TCP.
It needs TCP, but it needs to provide the IP address, okay, and all it has at this time is A, like the user puts telnet A instead of putting telnet directly an IP address, okay? Meaning, before we can open that TCP connection, we have to resolve that name, okay? And who can we ask? DNS client on machine C, okay? So we say, hey, what is the IP address for this name? One thing that you should remember is that while it looks like a good thing to do, it looks like it would be good that we cache the IP addresses for names, like Google, we use it so often, right? We should cache its IP address. This is something on the internet we say don't do that for DNS, okay? We should not cache for the name, for the IP addresses. You should all the time try to resolve. Yes?
Isn't that what the host file does?
Huh?
Isn't that what the host file does? I thought that the host file caches DNS names with the IP.
So, as I say, if you read the RFCs, they say that's completely, you should not do that. Now, you have always nuts that implement things in one way or another, and most of the time, because it looks a good idea, we should cache. But, and you can find it, try to resolve Google at different times. It will give you different IP addresses. Because Google may push you to go to different servers depending on the loads it has. Meaning, for some services, it's not the same IP. So if you cache, you may be always going to some machine that is too loaded. Okay? So don't cache. Okay? So whenever we have to resolve, we give it to the DNS. DNS will try to solve that IP address. Okay? So now DNS has this problem. He has to go, okay? So now he will look at where is my DNS server, right? And we said the machine C will know where is the DNS. It will have its IP address, okay? But hey, DNS use which transport protocol to send a request? UDP. So now, one thing, since you're UDP could use TCP. It could. But 99.99999, we use UDP because, as you can imagine, it's just one transaction. I ask, you answer me. Okay? While if you use TCP, remember I have that handshake. We don't want that. So DNS will ask UDP, hey, send this question, okay, to my DNS server. He gives this to UDP. UDP will put, hey, it will put the port numbers and so on. It's going to port number 53, right? So UDP will say, hey, so which protocol will UDP use at the network layer? IP. So we will give IP, we will give it the IP address of DNS, which is 14.2, and we'll tell, hey, can you send this? Now IP, the dense, right? Dense. First question? Is this for me? Is this for me?
No.
No. Second question? Is it local? Is it local? No, it's not local. And how do you know it's not local?
Because the second segment is different.
Yeah, normally if you went and do the mask over 24 bits, okay, you will find out that C has he's on network 131.204.27, while the destination is on 131.204.14.2. The network IDs are different. This is what tells me they are not local. It's not by, I see, this is a router. No, the machines do not see themselves, okay? Right? Patrick, any problem? No? Okay. So it's different than, so in that case, that means I have to give it to a router. How do I know which router? I have to look at the routing table on C, okay? Now, the routing table, let us go and look at the routing table. So here, we are giving the routing table for A. We are giving the routing table for B. And this is the routing table for C. The routing table for the DNS. And we have something for the router X. We have a routing table for each one, and this will be on each machine. So now if you look at C, okay, which entry will I choose? You see, normally we want to go to Of course, starting with 131.204. So which entry is good for me? On routing table C. So you should read it this way. This is the destination I want to. This is the destination where I want to go. This tells me what net mask I should use, okay, to extract where I want. And then this is the router to use. Which router should I use to send this thing? So now which entry on the router should I pick?
The first one to see.
Yeah, it looks like the first one is an exact match. It's an exact match, okay? And if we did not find the match, okay, like this one is exactly where I want to go, right? If I did not find this match, I would take the default out, okay? So when you don't find the match, you have to go and say, let me look at what is, this one is the by default, and by default, I should be going to this router, okay? And it happens the two routers here are the same, okay? So this tells me I have to go to router 254. So far so good? So this is something that we did not do. We should have done it. What are the IP addresses of the router? So the router, and observe something, the router has two IP addresses. Remember what we said, an IP address does not identify a host. It identifies an interface, okay? So can someone tell me what is the IP address of the router X at this point here?
27251.
So let us look. Yes, okay. Router on segment 3. On segment 3, it has 27.254. Right? And on this side, what is its IP address? On segment 1.
14.254.
Yes, it is 14.254. Right? Now, the Ethernet address are E on this side, EX3, and on this side, it's EX1. Please stop me if something is unclear. I'm telling you, your friends who are already close to the turkey, they would be grateful. Okay? So the router told us we have to go to 27.254, right? So here is the host, the C, the IP on host C. It has something, it has to send it to the router, okay? It knows its IP address, right? But hey, what do I need to send this thing? The MAC address, okay? Do we know the MAC address? No, we don't know the MAC address, okay? So let us put the ARP caches of everybody. A, for the ARP, it has IP, MAC, B, C, D, and the router also has an ARP. The X router has also, okay? So, C, the IP on C wants the MAC address. So he asked ARP, right? Now ARP, what does ARP do?
It checks the cache.
It's cache. Does C has anything in its ARP? No, at the beginning it's empty, right? Oh, it's empty, then that means ARP will have, and you can see here, it's ARP now, he's in charge of that thing. IP is there like just a McDonald's customer waiting for his sandwich, okay, right? So ARP is taking care, cooking and so on. So he says ARP needs to do what in order to get that MAC address?
Broadcast it out.
He needs to do a broadcast. Okay, so what will be the first packet to appear? On which segment first?
3.
It will be X. Okay. Now, question to you: will it appear on one?
No.
No, it will not appear. A broadcast is second layer broadcast, right? It's on the network on which you are. Okay, so it will appear on 3. So what is the destination? FF. Who is sending this?
EC.
EC. It's host C who's sending. What is the type?
ARP request.
Yeah, it's an ARP request. What is the source asking for this?
27.10.
Yeah, 27.10, looking for,
20.
so looking for,
27.254.
yes, it's looking for the router, right? So the mistake would be to say it is looking for the DNS, right? No, at this time we are just trying to reach the router, okay? So now this packet will be seen only by the router. Like if I look at this thing, there is only, on segment 3, there is C and the router that are there. So C will see, oh, that's a broadcast, right? It's a broadcast. Then it will pick that frame. Inside that frame, it will see what is the type. Oh, the type is ARP. Oh, if it is ARP, give it to ARP. It gets to ARP. What will ARP do?
Performs it in its cache.
Now, first thing, is it for me?
But
Is the IP address the same as what they are looking for, right? That's the first question.
I thought it checks to see if it's in the cache first.
Huh?
I thought it checks to see if it's in the cache.
No, but look here.
He didn't answer what the IT does because he didn't answer
ARP, ARP is saying, who has this IP address? That's the question that comes. And I'm ARP. I'm ARP. So I'm getting that question of someone saying, who has this IP address that is 27.254? Okay? So I'm ARP, I get that question. So I ask it to myself. Am I the one who has this IP address? If it's not me, I stay silent. I just drop that question. Okay? It's a kind of, you know, in the old days, you would have a hall, like in the dorms, you have a lot of rooms, okay? And the phone would ring at the hall and some good guy or girl would go and answer, right? And someone said, I want John Taylor. So do you think, so what they would do is just they would shout in the hall, hey, John Taylor! So everybody in the hall will hear that thing. So do you think that everybody goes and says, that's not me? No, that's not that. We just stay quiet. It's like art. So who would be going out? John Taylor. Say, oh, that's me, okay? Right? So here ARP will say, oh, since it's me, it's only then that he will update the cache. Okay, because he knows he's looking for me, then that means I may need to talk to him. Then router X will remember that, so which IP address will he put down? 27.10, and what is the MAC address? EC. Okay? After he did that, he has to respond, right? he has to respond, okay? He has to respond, and he will send it back. So what will be appearing? On which segment will we have something appearing? 3. What is the destination?
EB.
E what?
EC.
EC. Yeah, we are responding. Who is sending this?
27.27.
How much?
Oh, I'm sorry.
Ah, there is he. He wanted to give me the IP address. Okay.
EX3.
Yeah, we have to use the MAC address. EX3. Okay.
I'm writing ahead of you and I was.
Okay. What is the type?
ARP response.
Yes, it's an ARP response. Source?
27.254.
Yes. Destination? 2710. Okay. So this, okay, is coming to host C. So host C looks at the frame. Destination is me. Pick it. Pick it. Look at the type. Oh, it's an ARP. It's an ARP. Give it to ARP. And the ARP is waiting for his question, right? Okay. And he looks and he says, oh, now I know. So which cache will we be updating?
C's.
Yeah, so what will I put as an IP address here? 27.254. And what is the address I put here?
EX3.
EX3. Okay? Now we have the MAC address and we say to IP, hey, just give me that, okay? We will give to the link layer where you should be sending this. Okay? So now, where will appear the next packet?
3.
3. What is the destination?
EX3.
EX3. We are sending. Aaron is not here, and he's the one who suggested this time. Okay. Hey, Aaron, I selected this time just for you. Okay. Everybody, what should we do to him?
You should give us bonus points.
And then we take points from Aaron and give it to the ones from you. No, eat your turkey. We will not do that to you. Okay. So, what is the source?
EC.
EC. What is the type?
What were we trying to do again?
DNS request.
You see, now you have to remember where I was, right? What is it that we were trying to send?
DNS request.
It was the DNS request, and the DNS request is sent through UDP, who uses IP, which means what would be here? An IP packet. Okay? Now, here's where okay. What is the source? Who is sending this request? Who is sending this request? 27.10. That's host C, right? Now, who is the destination?
Oh, it's the DNS server.
So which IP address should I put here?
14.2.
Yes. And this is one thing that tells you, because you see, so far, and this is most of students, and Aaron, by the way, you were saying, why do we need MAC addresses? Okay? Just use IP addresses. You can see here, I am sending this to a machine that is not the last destination. The destination is the DNS, okay, the final. But on the network, my destination is that router through which I am going. That's one of the differences that you can see on your packet at this time. Okay? Now, what is the protocol number?
17.
How much?
17.
Yeah, 17. What is at the application level, we have the port number 53, and this is our DNS request, right? So, that frame went on 3, right? Who will pick it up? The router. The router will look at what is the destination. Destination is EX3, right? So it's for me, right? So he will pick it. He will look at the type. What is the type? IP, then I give it to IP. And I want you to observe something. Each protocol look only at the information of its header. Remember that the type is a part of the Ethernet header. Okay? So Ethernet look, oh, this is IP. Then I give it to IP. Okay? So IP will get that thing. So what will IP do? First question. Is it for me? Is it for this router? It's not, okay? The MAC address maybe is for me, but now we are talking IP. IP, the destination is 14.2. Then it's not me, right? Second question.
Is it local?
Is it local? Now, is it local?
Yes. Ish. Sort of.
Now, okay, someone, okay, but I understand what is the hesitation. For the router will try to find if he has some interface that is local to that destination. So does he have some destination?
Yes.
Yes. Okay. He has the other interface, EX1, is local to the other side. Okay? Then he would say that's local. Right? So he could send it to DNS, right? But he needs what?
MAC address.
MAC address. Oh, he needs the MAC address, right? Then we ask who? ARP. Ask ARP, hey, what is the MAC address of this IP address? What will ARP do before that? Checking the cache. So in the router, do we have anything there about DNS? No, it's not in the cache then, right? Then I send that request, okay? So now this request will appear on which segment?
1 and
1 and
2.
2.
1 and 2, okay? What is destination?
FF.
FF. What is the source?
EX1.
EX, how much?
1.
Yes, okay, that we are sending on that, right? What is the type? It's an ARP request. What is the source?
14.224.
How much?
Is it 14.254?
14.254, okay? And then, what is destination we are looking for? 14.2, okay? So, what are the machines? Okay, so now, the bridge. Okay, or what are the machines that will be seeing that? Machine A will see that broadcast. It will pick that frame. It will see its ARP. So it will give it to its own ARP. And inside that ARP, the question is, who has this IP address? Is it A? So A will stay quiet. B, also ARP will get that question. It will stay quiet. Then it will come, also the bridge will see that. So the bridge is seeing for the first time something coming from the router. So what will it learn?
The MAC address in the port.
Of who?
The router.
Of the router. So it will learn that which address?
EX1.
EX1. is on which port?
Port 1.
On port 1. Right? Now, it's a broadcast. Since it's broadcast, the bridge will let it go. Which means, who will also see this request? DNS. DNS will see that, oh, that's me. So what will DNS do? Okay, now, it comes to the DNS, gets to the link layer. Link layer, we say, oh, that's an ARP. We'll give it to ARP on the DNS. ARP on the DNS, what will it do? Yeah, after saying that's me, right? What will it record? What will it record?
14.2.
So it will record,
The IP address being.
yeah, it will be 14,254. That means the, and then what is the MAC address?
EX1.
EX1. Okay? And then it will respond, right? It will respond. So it will respond. So what it will respond will appear where?
2 and 1.
On 2 and on 1. Will it appear on 3? No. Okay. Now, who is sending these? To who are we sending these?
EX1.
To EX1. Who is sending these?
ED.
ED. What is the type?
ARP response.
It's an ARP response. Who is the source?
14.2.
14.2. Who is the destination?
14.2.
14.254. Okay. Now the bridge see this thing, right? Okay, he sees this thing. So first things, he looks at who is the source, who is sending this. Oh, it's ED, and remember the bridge learned through the source. So that means he will learn where is D. And therefore, what he will be put here,
ED.
ED, is where?
Port
J2.
2.
On 2. Okay? Now, question to you, will the bridge forward this packet? Will he forward this?
Yes.
Yes, because he knows that EX1, right, EX1 is on port 1. And this thing is coming from port 2, right? Therefore, the bridge will have to forward. And this is the reason why it appears on 1. Okay? Now, when it appears on 1, B will see this frame going to EX1. Oh, it's going to X1. It does not even go to the link layer. After just they read, that's not for me, right? A will also see this thing. It's not for me. Router will see its own address. So in that case, it looks who sent that, what is the type? And remember, this is Ethernet. It looks, oh, this is ARP. Push it to ARP. Okay? Now ARP was sitting, waiting for the answer. And we know that the MAC address is ED. Right? So where will appear the next thing?
Don't we need to,
Oh yeah. On the router, right?
yeah,
On the router we should learn about who?
14.2.
14.2
ED.
ED. Okay? Thank you for that. So what is the next thing that will appear?
The DNS request.
Yeah, and it will be on which thing it will appear? On which segment?
1 and 2.
1 and 2. What is the destination?
ED.
ED. Who is sending these?
EX1.
EX1. What is the type?
IP.
That means it is this packet that we are trying to send. Okay? IP. What is the source?
14.254.
What? Who is sending this?
Oh.
Who asked the request?
What?
27.10.
Yeah, we don't change that. And this is again where you have to make the difference between MAC address. Yeah, it's the router who is sending that, but the request is sent by host C. Okay? So now, who is the destination? It's 14.2.
So does it just hold that request while it does the arc slow?
You bet this is what we want to send, right? So he will keep it until he has all the information to send.
And then keep it.
Yeah, we had that packet that we wanted to forward, right? Okay?
So, its cache could fill up then, right? If it,
Oh yeah. And this is what we are talking about, congestion control, right? If there are too many packets coming to the router, the queues can get full and packets can get dropped. Now for the final, we assume that the routers will not drop any packets, okay? Because one thing you can say is that, oh, all routers are full, nothing will appear on the wires, okay? So what is the protocol number? 17. It's in fact this packet that will appear. What is the port number? 53. It's our DNS request. Okay?
Response.
Huh? It's still the DNS request, remember? So you have to keep track, okay? C send request that reached this thing reached the router, and the router tried to forward this packet. Okay, so if you can see, this packet went on segment 3, and now it is traveling on 1 and 2 toward the destination. So it's still the question, because it did not yet reach the DNS, right? DNS server. So now, which machine will see this frame? Which machines will see this frame? Which machine?
Only the DNS.
No, but they will see at least these.
All of them will see it.
Yeah, all of them, they will see this, okay? But they will ignore it because it's not for them. Now, the bridge, let us look at the bridge. The bridge received that thing that has to go to ED. Will he forward?
Yes.
Yes, he has, because when he looks, ED is on port 2, and something is coming from port 1. Then I have to forward, okay? And finally, which host will see this thing? After it goes through the bridge? D, right? The DNS will see that. Yeah, so now DNS we say, oh, this is for me, right? Okay. What is the type? Oh, it's IP, so I give it to IP, right? IP, now you can see IP itself will look and say, hey, what is the destination? First question,
Is it for me?
is this for me? Is this for me?
Yes.
Yes, I am 14.2. Oh, if it is for me, then I have to push it up. To who should I push it up? To 17, UDP, right? So UDP will get that thing, okay? It will get that thing and it will look at the port number. Oh, this is for the DNS server. It will be pushed at the application layer to DNS server. Now the DNS server got the question, okay? And it has a database with those names, and so it will answer by switching the port numbers and switching the IP addresses. You see what will happen now is that those things will be switched. The destination will become C, and the source will become the DNS. Ports also will be switched, okay? DNS server will become the source, and the client will be the destination, okay? So now, the DNS, in order to answer, will use which protocol, which transport protocol to respond?
17.
His name, UDP. UDP, which has now UDP needs which protocol to send that datagram? It gives it to IP. IP dense.
Is it for me?
Is it for me? Is it for me?
No.
No. Is it local?
No.
It's not. And the way it finds it's not local is by, again, doing that masking and finding that its network where it is different from the network of the destination. That means it has to go through a router. So what will it go look for? Where will it find the router?
It's the MAC address, right?
MAC address? Where is he?
It needs the MAC address of the router, right?
It looks
No, it needs to look into what?
Oh,
looks
it's
like
routing
stash.
table. It's routing
Not-
table.
Routing tables. Routing tables. We have to go into the routing tables to see. Okay, so now routing table is on the next slide, okay? So I am the DNS. So on the DNS, what are the entries we have on the DNS?
It's the default.
Only the default. And that means anything that I have to send, I will have to send it to the router 14254. Right? Okay? So we know that we have to send that to that guy. Okay? Right? So now IP needs to send to that address. Okay? He knows the router. Okay? Now, question, in order to deliver it to the router, what does he need?
MAC address.
The MAC address. Oh, we need the MAC address, so IP will ask who for that? ARP. So we ask it to ARP. Now, what will ARP do?
It's cache.
It looks in this cache. Now, look into the cache of the D host. What is there? We have the MAC address. Okay? How come we have it?
From a previous interaction.
Because the intersection, right? Remember when the router were asking for the DNS? DNS remembered that address. Okay? So, which means ARP now will immediately give the MAC address. Okay? So now tell me what will appear and where. So where will appear the next frame?
1 and 2.
So it will appear on 2 first and 1, right?
Do I have to put them in that order?
It's just to remember, right? Okay, because that's the time, right? Now, what will be the destination?
EX1.
EX1. Who is the source?
ED.
ED. What is the type?
IP.
IP. What is the source?
14.2.
14.2. What is the destination? How much?
27.10.
Come on! It is 14.254.
No.
No! Right, thank you, okay? I can. Yeah, it's 2. The mistake would be to say, I'm sending it to the router. No! That response is for C, not for the router.
Still wrong.
Oh, yeah. Send it to myself. So it will be going to 27.10, right? That's the address of C, okay? Because remember we said we switch the IP addresses, okay? Now what is the protocol number?
17.
It's still 17. What is the port number?
We don't know.
We don't know here. It's just the client port, okay? Right? And this one is the DNS response. Which machine will pick this frame? Only the router, right? So it will come to him, Oh, at the link layer, it says that's for me, right? It looks at the type. What is the type?
IP.
Oh, that's IP, okay? Then it will push it to IP. It gets to IP. IP dense? Is it for me? Is it for him? No, it's not for him. Second question, is it local to some interface? Is it? Yes, it is local. Now, since it's local, right, then we need the MAC address to where we want to send, right? So IP will ask who to get the MAC address? ARP. It will ask that to ARP. So now, what will ARP do? It will, so let us check the ARP of the, do we have IP address 2710?
Yes.
Yeah, we have it, right? Which means we have immediately that MAC address. Which means, what will be the next frame that will appear on which segment?
3.
On 3. What will be the destination? EC. Who is sending these?
EX3.
EX3. What is the type? IP. What is the source?
14.2.
It's the DNS. What is the destination? Protocol number?
17.
What is the port number?
Unknown.
Unknown. And it's our DNS response. Right? So far, so good? Okay? So, now, who will be picking this frame? C. So C will get it. Okay? At the link layer, we will look at to who is it. Right? It's IP. Push it to IP. It gets to IP. IP dense. First question.
For me.
Is it for me? Yes. If it's for me, I have to look. Protocol. Oh, that's 17. I have to give it to UDP. It goes to UDP, right? When it goes to UDP, UDP look at the source destination on its header. And that would be the port number of the client that was asking that question. So he will give it that response. Okay? So now the DNS client on C got the answer. Right? Now it looks like telnet and we have the IP address now. So I want you to observe something. Is that when you were thinking, I am doing telnet, right? Look at how many frames were exchanged. We did not yet start the connection. We were just looking for resolving that IP address. Okay? This is the reason why sometimes the first thing you are doing can take some time. Okay? So now, telnet got that thing, right? Telnet, he has the IP address. So now, which who will be doing now? Which transport layer will he?
TCP.
Yeah, he will say to TCPA, please open a connection with so-and-so IP address, right? Okay? So now what does TCP will form to send first?
SYN.
The SYN. He wants to send the SYN, okay? He wants to send the SYN, he has the IP address where he has to send it, so to which network layer he will give that SYN? To IP. IP is the horse. Okay, when I say at the network layer, there is no other choice at the moment. It's IP. Really, it's the, we call it the workhorse of the internet. Okay, we give it to IP. IP dense. First question. Is it for me? No, it's not for me. Second question. Is it local?
No.
It's not local because we want to send to A, right? And if you look at the IP addresses, A has 14.173. C has 2710. It's not local. If it's not local, what should we do? Look into the routing table. So let us look on the routing tables, okay? And the routing tables on C, do we have a match of a network to go. And it happens that we have an exact match. We have to send to this router, 27 to 54, right? So here is IP, right? Who wants to send that thing, right? And he needs what? He knows the IP address, but he needs
MAC address.
the MAC address, right? Oh, he needs the MAC address. So who will we ask? ARP. So he will ask ARP and say, hey, I want to send that. Now, what will ARP do? Check his cache. Now, do we have in the cache of the router, of C, do we have the MAC address?
Yes.
Yes, we already have it. So if we already have it, can you tell me what will be the next frame? Which will be appear? It will be 3. What will be the destination?
EX3.
EX3. Who is sending it?
EC.
EC. What is the type?
IP.
It's IP. What is the source?
27.10.
2710. Who is the destination? Ah. What is the IP destination of
The
that?
one that DNS responded with.
No, it's a 14173.
Now we are trying to send our SYN packet, right?
Yeah.
To which machine?
14.
A, right?
14.10.
So it is going to, so what is its address? It's 14 point for A.
173.
It's, yeah, 173. What is the port number, protocol number?
6.
It's 6. That's TCP, right? So far we have UDP, 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 UDP. Okay? What is the port number we are sending this to?
23.
23. That's our SYN segment going to telnet, right? The application is telnet, okay? Now, which machine will pick this frame?
The router.
The router will pick this frame. So he will take it, right? And he will look at what is the guy who gets these? IP. Push it to IP. IP will do his dance, looking at destination address. First question,
Is it
is
for me?
it for me? Is it for me?
No.
No, this is not my IP address. Second question, is it local to someone on my interface? Yeah, it's local. Or if it's local, right, I need the MAC address. So who will IP ask? ARP. We'll ask ARP. Now, what will ARP do? It will check his cache to see if it has this IP address. Does he have that IP address?
No.
No, it's not there. So if it does not have it, what will it do? It will broadcast. So what will appear? On which segment?
1 and 2.
So it will be appearing on 1 and 2, and it will be, destination will be FF. Who is sending this? EX1. What is the type?
Our request.
It's an ARP. Request. Okay. Who is the source?
14.25.
Who?
14.254.
So 14 point.
254.
Yes, that's the router, right? And we are looking for who?
14.173.
Yes, we are looking for. Now, all machines will see that thing and they will pick it and they will find it's for RP and all of them will give them to their RP.
Yeah.
People not concerned will not respond. Only machine A will respond. Okay, which will get it, give it to ARP. So what will happen on machine A?
It'll see that it's for it and then record it in its cache.
Yes, so what will it put as a value here?
14.254.
14.254. And what will it put as a MAC here?
EX1.
EX1. And it will respond, right? It will respond. So what will appear? Oh, by the way, will the bridge forward this? That's interesting, okay? These things, you said, yeah, 1, 2, yeah, it did it. Oh, now it's the response. Okay, so now the response. So the response will appear on where?
Just one.
Okay, now it will appear on 1. Why it does not appear on 2?
Because it knows that EX1 is on the floor.
Yes, the bridge knows that EX1 is there. So you see that bridge that is now filtering and isolating the traffic. If it's not needed, we should not send it there. Okay? So it will appear on 1. What will be the destination? EX1. What will be the source? EA. What is the type?
Our response.
Response. What is the source?
14.173.
Yes. What is the destination?
14.254.
Yeah. Right? So now the machine, the router will pick that, okay? Even though B will see that and so on, it's only the router will pick this. It will pick that, say this is for ARP, right? Then what will happen?
ARP will see if it's me.
Yeah, it will be for him. Remember, that's the response now.
Right, then record it in its cache.
Yes. So who will be putting this? Which machine will be?
Router X.
The router. So which value will he put here?
14.173.
4173
Yeah.
and
EA.
EN. Right? Now he has the, right? The router has the MAC address of A. Yes.
When EA responded and put it on segment 1, the bridge would have seen that. Does that mean the bridge would have, since it saw the source, it would still record where
Oh,
EA
by
is?
the way, oh, that's very good. Okay. The source, when this answered, yeah, this is what I was, yeah, when A answered, remember that's the source. The bridge sees it, right? So what will it learn?
Where EA is?
It will learn where is A. So what will we have here?
EA, E1.
EA, and it will be on port 1. So the bridge will learn about A. Okay? So now what will be the next thing that will appear and where?
The
One.
same
One.
Yeah, it will appear on 1. Who is the destination?
EA.
EA. Who is sending these?
EX1.
EX1. And what is it? It's an IP. In fact, it's this thing. And what is the source?
27.2.
What is the destination? What is the port number? The protocol number?
6.
6, that's TCP. And what is the port number?
23.
It's 23. That's our SIM segment. That's for telnet. Right?
Yes.
This thing will be seen by B, right? Will it be seen by the DNS? No, it's not. It stays only on segment 1. Okay? So machine A will say, oh, this is for me. What is the type? Type is IP, so we give it to IP. IP dance, is it for me? Yes, this one is for me. Oh, it's for me, then we have to push it up. To who?
TCP.
IP will look at the protocol number. 6, give it to TCP. TCP will get that thing and look at the port number. Oh, this is something normally that should be given to the telnet, but it's just the SIN, right? And the SYN calls for TCP to send a SYN ACK, right? So TCP will send back a SYN ACK from machine A. So now it's going back, right? So TCP uses who? So and remember, TCP will switch the IP addresses, so he will know what is the destination to send to, right? He will switch the port numbers, okay? Source will become 23, the telnet server, right? So TCP will give this to who? IP. It gets to IP dense. Is it for me?
No.
No. Okay. Second question, is it local?
No.
It's not local. Then it has to look in the routing table, right? So, routing table, which routing table should we look into?
A's.
Yes, it's the machine A who is looking. And we are trying to send to 131, 240, you remember C? And it looks, this one, I have a match, I have a good match for the first entry of the routing table. And it says, what is the IP address where I should be sending, which router? 14.254, right? So IP now needs to send that thing. It needs
MAC address.
a MAC address. Who is asked for that?
Or
ARP, right? So we give it to ARP. Now what will ARP do?
check cache.
It checks ad. That's a big one. I did not do it. I swear. So, in its cache, okay? So do we have that IP address?
Yes.
Yes, it's there, and it says that MAC, which means immediately we have the MAC address. So can you tell me on which segment will appear these? One. To who are we sending these?
EX1.
X1. Who is sending it?
EA.
What is the protocol? IP. What is the type? Okay. What is the source? Yes, it's A, machine A that is sending this. To who are we sending these?
27.10.
Yes, we are sending to C. What is the protocol number?
6.
6. It's TCP. What is the port number?
Unknown.
We don't know, right? Okay, that's the client. But here we have that SYN ACK, right? Or ACK. And that's for telnet, right? So the person who will be picking up will be the router. The router gets it, right? What is the type? It's IP. Push it to IP. Dense of IP.
Is it for me?
Is it for me?
No.
No. Is it local?
Yes.
Yeah, it's local to one of my interfaces, right? Then I have just to find where to send it, right? I need the MAC address. So do we have, so we will ask who? ARP. So what will ARP do?
Check its cache.
Yeah, so do we have that in the cache?
Yes.
Yes, we have it. Which means what will appear and where, which segment will it disappear? Yes. Who is
EC.
destination?
EC.
EC. Who is sending it?
EX3.
EX3.
IP.
IP. What is the source?
14.173.
Yes. What is the source? Destination?
27.10.
27.10. What is the protocol number? 6. Still the same thing. Port number?
Unknown.
And that's our SYN ACK. Host C will pick that frame. It will pick it, it will say, for who it is, oh, it's type IP, push it to IP. IP dense, do it for now. What is the IP dance? What will the IP do? Is it for me? Is it for me?
Yes.
He says no.
Yeah.
He said no. He said no. Come on, it's game. The destination is 2710, right? Now, it is for me, okay? It is for me. Then we look at the protocol number. IP will look at the protocol number. Oh, this is 6, so give it to TCP. TCP gets it. Look at the port number. Oh, that's for the client, right? That is it. Oh, and that's the SYN ACK. Oh, that's the SYN ACK. Then that means now we have to send the ACK, right? TCP needs to send the ACK from host C, okay? So it is going back. Yeah. So TCP uses which protocol at the network layer? IP. It gives him the IP address, okay, right? So IP dance. Is it for me? No. Is it local? It's not local. Oh, I need to look at the routing table. Okay. We look at the routing table for for C, right? And we find out that if you want to go, that's the way to go, right? So now IP has to send it to the router. It needs a MAC address. It asks who? ARP. So ARP. What does ARP do?
Checks the cache.
It looks at cache. Does it have that thing?
Yes.
Yeah, it has it, right? So what will appear?
3.
Which segment?
3.
3. Who is sending? To who are we sending?
EX3.
To EX3. Who is sending that?
EC.
EC. What is the type?
IP.
IP. What is the source? 2710, right? Who are we sending this to? 14.173. What is the protocol number?
6.
6. It's TCP. What is the port number here?
23.
23. We're sending back to that server, right? And this one is the ACK. Right? The router will pick this. It will pick it. It will say, what is the type? Oh, it's IP. Push it to IP. Right? Each time I get to IP, he starts smiling, okay? Maybe you should tape all the time. Because it looks like a show or something. So, it gets to IP, right? First question. So, destination is this guy, right? So, is it for me? It's at the router. Now he's saying yes. Well, at the router, and it's going to A, right? Okay, so the answer is no, right? So if it's not no, then the second question, is it local? It's the third question. Is it local to one of my interfaces?
Yes.
Yes, it's local. So if it's local, I need just the MAC address, right? Okay, to deliver to this guy here, okay? So IP will ask who? ARP. What will ARP do? So let us check. Do we have?
Yes, we do.
Yeah, we have it. We know EA, right? So in that case, we can send that. So where will this appear?
1.
On 1. Destination is
EA.
EA. Why it doesn't appear on 2?
Because the bridge knows where EA is.
Because the bridge knows where A is, so he does not have to forward, okay? Who is sending these? EX1. The type is IP. The source is, the destination is
14.173.
It's 6. It's the same port number, 23. It's our ACK that will be picked up my machine A, okay, that will say give it to IP, right? And the IP will look at the protocol number, say this is for TCP. TCP says it act, let us start dancing or chatting or whatever. Any question?
For packing.
Don't tell me I did not understand anything.
For packet tracing on our final, will you just give us a really long problem like this to work out, or
You did not yet look at your homework.
I did not?
Okay, so let me show you. That will give you an idea of the kind of things.
No worry, you'll get back to it. I remembered it.
Then I stopped. So I got to like tell her.
I haven't done it.
So here is, you can see the network that you have for the homework, okay? It's nice, it's like, there are multiple segments, there are multiple, there are 3 routers, 2 bridges, okay? And one thing, and one way to show you is that I think even on the homework, there is one thing. Don't think that when a packet is going from one source to a second destination, when it returns, it will always return from the same thing. Don't do that. Don't say, oh, I know the route. No, 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 no. Keep looking at the routing tables. Because what may happen is that the packet, when it comes back, the response like TCP SYN or like DNS request, what may happen is that it will come maybe from a different route. And this may be happening on the homework and may happen on the final. Right? And in some sense, on the final, you would have something similar. Yes?
Now, will you stick to like telnet and HTTP where we know the port?
Oh, you mean the port numbers and things like that?
Like what port
Yeah, I
numbers do
would
we need
be.
to have memorized?
Yeah. You know, the mistake would be that I test you and you get frozen because you don't know the numbers. That's not the point. Okay? So this will be something like telnet or like, as you said, HTTP initiates a TCP connection, right?
Thank you.
Mm-hmm.
Are you saying that you'll have the numbers on the test? Or
Which numbers?
do you show the numbers that we need on the test, or do we have to remember those?
Yeah, okay. Let me tell you something about those numbers. I want you to remember it such that you know how to use them, okay? And mainly, oh, I'm sorry, guys. I should go and pray, okay? That's the time of my prayer. I told to God just to wait for me a little bit, okay? But mainly, I think after having done computer network class, there are some numbers to know, like that makes you a little bit different from others, okay? I think almost everybody, even people who do not know network, they know HTTP is on 80, okay? Of course, they don't know TCP is 6 and UDP, but I want you to remember those numbers, just like what I told you, those rocks that I want to put on you. Do you know the story of the rocks? What I mean by rocks? You know, the Marines, when they train, okay? We want them to be strong enough to run like let's say 5 miles, okay, with about 100 pounds on their back, right? So when we want to train them on that, on their back, we don't put the gun and the food, okay, because they don't, but we put just rocks on their backs. Just rocks. The rocks are not useful, but they build that capacity to run. Right? That's what I'm doing. And so I'm using those numbers. Those numbers you can Google, right? When you will be. But the fact to know them, you know, oh, this is a protocol number, it is a disposition, and this is how it is used. Okay. So I want you to know the 17, the 6, the DNS, the 53, the HTTP. Okay. Those numbers. Any other question? Okay.
Actually, is 254 a common final number in the IP address of a router?
254?
Right.
Yeah, like most of the time, people, what they do is that they put for the routers at the end of the spectrum. It comes from the old days, like when they were giving the dynamic addresses. Not dynamic, the guy has to assign IP addresses forever. So what they would do is that they would say, when users are coming, I will give them starting 1, 2, 3, 4, right? And then when I have routers and things, I start on the other side, okay? But normally, it's just human being doing this kind of choices, okay? And sometimes even people forget why they are doing things. They just do it. You know the story of the culture, what we call culture. Sometimes like people do something to the point that they don't know why they are doing it. You know that experience that they did with the monkeys? Okay, so let us finish on that one, okay? For YouTube, they will have that at least, okay? That goes with the turkey. They can tell that story. So here is the experiment they did, okay? They put some monkeys in a cage, okay? And there is a banana, okay, in the middle of, and you can imagine the monkey, as soon as it sees a banana, it jumps on it. But when it jumped on it, the researchers, what they would do, they put a lot of cold water on the cage. And they don't like cold water, okay? So the monkeys, they learned quickly that, hey, even if the banana is there, I'm not going for it, okay? I just leave it. So here's what they did. They introduced a new monkey in the cage. What do you think the new monkey will do? He sees the banana.
Gonna get the banana.
He will try to get it. Now, what do you think the other monkeys will do to him?
You're gonna stop him.
They will stop him. They will jump on him. They will beat him. Hey, don't touch that banana. Okay? Which means, as they introduce monkeys, those monkeys, in fact, when they try to reach the banana, the other monkeys, they stop them. Which means the new monkeys do not know that there is a cold shower happening, right? And then what they do is that they remove the monkeys that knew the shower, little by little, and they leave monkeys that never had ever a shower. And they bring in a new monkey. What do you think the new monkey do? It will try to reach the banana. What will the other monkeys do? Do they know why? They don't know exactly. This is what we call the culture, like of companies. So sometimes people, they do in a company, they just do it. Why are we doing this way? Maybe the reason comes from the old days when they were using horses, which means by now we should not be doing this anymore. Okay? So have a good Thanksgiving and safe Thanksgiving.